Hello everyone, welcome to IAS Brains. Prelims 2022 is fast approaching and I am sure all of you all are already into the preparation. From today, IAS Brains is launching an exclusive current affairs program called Current Affairs Digest 2021-22. Through this program, we intend to bring to you interesting discussions related to core subjects like your Indian polity, Indian economy, science and technology, environment and ecology, international relations, and various other social issues. I'm sure these sessions will give you a holistic perspective which will help you not just for hacking your prelims 2022 but even your mains as well as interview. To continue watching our videos, kindly subscribe to our channel IAS Brains, and yes, do not forget to even press the bell icon. I wish you all the best. Enjoy watching our videos.
Hello students, welcome to online session of Geography. I am Syed Mohammad Aziz and today we will be discussing about the climatology topics. So in the climatology, today we will be discussing about the insolation and we will also discuss the factors affecting insolation, and in the end we will discuss some previous year questions and also some mock questions. So let us start with this topic called as insolation. Now in this topic, first we need to understand the center of the solar system, that is the sun. We know that sun is a star, and a star basically is a celestial body that basically emits light and heat. So if you look at the star, that is our sun, there is light and heat coming out of the sun, and it is due to something called as nuclear fusion reaction. Okay, so the nuclear fusion is happening among the hydrogen atoms in the center of the sun, that is in the core of the sun, and from the core of the sun we have the energy coming out of the sun, and the energy is basically traveling into the second zone, that is radiative zone, and from the radiative zone the heat and light are traveling into convective zone, then they are entering into chromosphere, then into photosphere, and then they are coming outside the sun and they are extending into the solar system. So this particular radiation that is coming out of the sun, okay, is basically referred as the solar radiation. So if you look at this solar radiation, they are emitted in all the directions from the sun, but Earth, since it is very small object in the solar system, it is going to intercept only a few part of the solar radiation. Okay, so how does this solar radiation comes out of the sun? In what form does it comes out? So solar radiations basically come out of the sun, okay, in the form of electric and magnetic waves or electric and magnetic field. Okay, so that is the reason why the rays coming out of the sun is basically referred as the electromagnetic spectrum. So it has both electrical waves, also the magnetic waves. Okay, and if you observe the speed with which it is traveling, okay, it is almost 3 into 10 power 8 meters per second, and this is what we call as the speed of the light. Okay, so it takes around 8 minutes 20 seconds for this light to reach the surface of the earth. Okay, and that is what we call as the time taken to reach the surface of the earth. That means whatever light you are experiencing right now has started its journey from the sun around 8 minutes 20 seconds ago. Okay, so that is what we call as solar radiation. Fine. Now solar radiation is in huge numbers, but the earth, since it is a very small body, it is going to intercept only part of the solar radiation. Now that part of solar radiation, okay, which is intercepted by the earth, is what we refer as the insolation. Remember this word insolation. So if I divide this word insolation into two groups, first is the incoming. In refers incoming and solation refers the solar radiation. So when we have the earth intercepting the part of the radiation, solar radiation, then that is basically referred as insolation. Okay, now what amount of insolation is basically observed by the earth? If you look at the amount of the radiation observed by the earth, it is around, you can see, 2 units out of 1 crore units. It is around 2 units of the energy that is intercepted by the earth, right? And that is what we have, the insolation. Now, whatever is intercepted by the Earth, it is in the form of the short wave radiation. Okay. Now, what is this short wave radiation? Short wave radiations are those radiations which have high frequency and they have a shorter wavelength. We all know that wavelength is inversely proportional to the frequency. So, since its frequency is very high, the wavelength is very small, right? So, that is what we have. The incoming solar radiation or the insolation is basically a short wave radiation. Okay. Now, if you observe the surface of the Earth is not a flat surface or is not a flat body, but it is a spherical body. So, this is the surface of the Earth. Now, since the surface of the Earth is curved, the central part of the Earth, which is directly exposed to the solar radiation, is going to receive the maximum heat, and that means it is going to receive the maximum insolation. So, you can see here that region which is actually present in the central part is basically referred as the tropical region. So, what exactly is tropical region? The region present between 23.5 degree north to 23.5 degree south. Okay. Now, this is the region which is referred as tropical region because it receives the maximum heat, and in fact it is present directly under the sun. Or you can say it like this, that the rays basically fall vertical on this particular region, and that is the reason why it receives the maximum insolation. Okay, you have maximum temperature, and in this zone you find the tropical forest, and the climatic regions here are completely different, right? Further moving ahead or moving towards the north and moving towards the south, you find that the rays are actually falling slantly, so something like this. Okay, that means the slant rays are going to cover more area, they are going to heat the more area, and that is why these regions are going to receive less heat when compared to the tropical regions. You can see here the the temperate regions are going to receive less heat, and further as you go towards the poles, you receive the minimum heat. So, this is the poles. Poles are going to receive the minimum insolation. Okay. So, that is what we have regarding the surface of the Earth and the insolation levels. Fine. So, next we need to observe that on the Earth also there are certain factors that basically vary or that basically change the amount of insolation that is received. We have around 6 factors you can see here. The first factor is the solar constant. Okay, that is basically defined by solar flares and solar plates, and they are going to also vary according to the sunspot cycle. Now, the second is rotation of the Earth. Okay, and the third factor is the angle of incidence of the sun rays and duration of the ray, transparency of the atmosphere. Also, you have the position of the Earth on the orbit. Okay, now we'll look into each of these factors individually and understand how they are going to vary. So, first factor is the solar constant. What is solar constant? If you see this word solar constant, there is a word called as constant. So, when we say constant, constant means something that is not going to change. Okay, but here the constant is going to vary slightly, but more or less it remains constant, right? Now, what is this constant? So, it is the amount of heat that is received by the Earth, okay, measured from certain height from the surface of the Earth. Let us say you have all this thing that is called as atmosphere. Okay. Now, we all know that the sunlight entering into the Earth will be refracted, will be dispersed by the atmosphere. Okay. So, there will be some kind of reflection, dispersion, okay, refraction, right. So, we will not be able to get the exact value of the heat that is received by the Earth if you measure it on the surface of the Earth. Now, that is the reason what you do is you measure the amount of heat received by the Earth at certain height above the Earth. So, this is the point where you measure the amount of heat that is received by the Earth. Now, that point, okay, might be around 1600 kilometers above the Earth, okay, and this is what you call as the amount of heat observed here is what we call as solar constant. And currently the solar constant is around, you can see, 1360 watts per meter square. So, if you take a meter, okay, something like this, a square of 1 meter, you find that this meter square is actually observing 1360 watts of intensity of energy. Okay, so you can convert that into other units depending on the requirement, and you will find that the value is going to slightly change. Now, sun is basically a star which has a kind of release of the fusion reactions, fusion reactions in a different way. So that's why, for example, in some years the sun is going to release more radiations, and in some years the sun is going to release less radiations. Now this variation is what we refer as sunspot cycle. Sunspot cycle. Now this sunspot cycle, is a 11-year cycle in which the maximum intensity released by the sun is in the 5th or 6th year. Now you can imagine that if the maximum energy released by the sun is in 5th and 6th year, so the maximum energy will also be received by the earth in 5th or 6th year, right? So that means the solar constant is not constant, but it is slightly going to vary, to a 0.2%, at the peak of 11-year solar cycle, or sunspot cycle. So that's what you have to understand. So then second factor is rotation of the earth on its axis. For example, you take this earth, so it is actually rotating on its axis. So you can observe that the part that is facing the sun will have day, and the part that is away from the sun will have the night. That means you have more temperature during the day. Let us say the temperature is around 30 degrees, and during the night the temperature is around 20 degrees, let us say, right? Now there is a variation in the temperature because there is a variation in the insolation. Now why do we have variation in the insolation? Because only half of the earth is facing the sun at a time. Now that is what we call as the rotation, and this is happening basically to the rotation, right? So this is the second factor that is going to change, or that is going to vary the amount of insolation. So you can see here, this is the circle of illumination, and this is the day part, and this is the night part. So you could observe that during the day the temperatures are different, during the night the temperatures are different. The third factor is the angle of incidence of the sun's rays. We have already discussed this thing in the first or second slides, where we have seen that the tropical part is going to receive more heat because the rays are falling vertically here, that is, they are perpendicular to the surface, and you see the rays keep falling slantly as they go towards the polar regions. So that means if you observe one single ray, it is going to heat only a small region or small area in this particular tropical region, whereas the area that is heated by one ray here is very large. So that's why the amount of heat is also less, right? So that means as you go towards the poles, the amount of heat also decreases, right? Because the insolation, in fact, insolation is constant. I mean, the rays that are coming, they are constant, but they are falling slantly here. So that is the second factor, right? So this is these are the zones that have been classified based on the amount of insolation received. I was already discussing about these things. This is called as tropical zone or torrid zone. This is called as temperate zone, and since it is a northern region, northern temperate zone, southern temperate zone, then we have the frigid zone, which is referred as polar zone, where the land is basically frozen throughout the year. So this is what the sun rays do in different parts of the earth. Next, the third factor is duration of the day. Now look at the duration, the third factor. Basically, you have the day, which is basically shorter in winters, and nights are longer in winters. Whereas in summers, days are longer and nights are shorter. You could clearly observe this difference when in winters the sunrise usually happens at around 7:30 in the morning, whereas the sun sets early in the winters, that is around 5:30, 6 o'clock in the evening, right? You can observe that the days, day is around 10 hours, whereas night is around 14 hours. So this kind of variation in the day and night, length of day and night, is also the reason, in the variation of the insolation, and is also the reason for the variation of the heat observed by the surface of the earth. So that is what we call as the duration of the day. Next, you can see here during the winters it is different, during the summers it is different. And why do we have this? Because the earth's axis is actually tilted, tilted at an angle of 23.5 degrees. So that is what we have. Further moving on, you can see here even during the seasons like winters and summers, you have this kind of variation. So during the winters, we have this kind of presence of the sun rays in the northern hemisphere, and this is the vertical sunrise in the southern hemisphere. In the summers, it is opposite. This is in the northern hemisphere and this is in the southern hemisphere. Okay. Then the next one is the transparency of the atmosphere. So the sun rays which are entering into the earth basically are bisected or is basically blocked by the atmosphere, is basically blocked by the clouds. Okay. So the dust particles that are present in the atmosphere. Now, the more transparent the atmosphere, the less the clouds, okay, the better the incoming solar radiation, okay, so or insolation. So if there are clouds and they are actually blocking or they are absorbing the sunlight, then what happens is it will not be able to reach the surface of the earth properly, right? So that is what we have. The transparency of the atmosphere is a very, very essential factor for the earth to absorb the solar radiation properly, okay. So further you can see the Perillion and Aphelion. What are these terms called as Perillion and Aphelion? Like let us say the earth is actually going around the sun. Now the orbit of the earth around the sun is actually elliptical, right? Now since it is elliptical, there are 2 points. In first point, the earth is away from the sun. In the second point, okay, in the orbit, the earth is very, very close to the sun. Now the point where the sun is the point where the earth is away from the sun is what we call as aphelion, okay. So it is the farthest from the sun. The point where the earth is closer to the sun is what we call as perihelion. Now you can observe that if the earth is closer to the sun, it would ultimately result in absorption of more insolation. If it is away from the sun, it would lead to lesser amount of insolation, right? The same thing happens in the aphelion and perihelion, and that's what we have this differentiation. That means if the earth is away from the sun during aphelion, the insolation will also be less, okay, and during the perihelion the insolation will be high. That means there is a change in insolation and that's a factor, okay. So you can see here this is the perihelion and this is the aphelion. And you could see the distance here, it is 147 million kilometers, whereas in the perihelion, in the aphelion, it is 152 million kilometers. So the average distance between the sun and the earth is around 150 million kilometers. Okay, it's the average of these two. So that is the next factor. So there is a question here. So try to solve this question. So this is based on the insolation. So this is a mock question. You can see that he is asking you to identify the correct options. Like he has given you 3 options. The first one is the incoming solar radiations on the earth is known as insolation. This is the first option, right? It is very much true because we have something called as the incoming solar radiation, that is insolation. So this is true. So if one is true, you can eliminate the D option because in the D option you don't have the first statement. The farthest distance of the earth from the sun is 152 million kilometers. That's on the 4th July. Okay, and this is also you can see that the second option is also true because it is the farthest point. Okay, so it is on the 4th July. Then the position of the earth when it is nearest to the sun is called as aphelion. Okay, so when the position of the sun is nearest to the something called as you can say the sun, the position of the earth nearest to the sun is actually not aphelion, it is perihelion. Okay, and here you can see the farthest distance of the earth from the sun is 152 million kilometers. It's on the 4th July. It's actually on the 3rd July. Okay, so that means the second and third statements are actually wrong. So by that way you get the option A as correct option. Okay, so next, second question, if you look at the second question, which of these factors are responsible for variation in insolation? The angle of inclination of the sun's rays. Okay, so we have already discussed that. This is the reason why we have the tropical, temperate and the polar regions. So A is true. Then the length of the day, I told you the duration of the day is the reason. So B is also true. Then see the third option, the transparency of the atmosphere. Okay, I already told you that the presence of the clouds will basically block the sunlight. So C is also true. So all of them are true and C is the answer here, right? So such questions can be asked in the preliminary exam. So here we have 3 more questions. If you look at the first question, a ray of light from the sun takes about 8 seconds to reach the earth. So he's saying a ray of light basically takes 8 seconds. No, it is 8 minutes 20 seconds. So the first option is actually wrong. Light from the moon takes only a second to reach the earth. Now see, the sunlight that is actually hitting the moon is reflected back onto the earth, and that usually takes 1 second. Okay, because the distance between the moon and the earth is 3,84,000 kilometers. Okay, so this second statement is correct. So you get the answer as only 2, that is B. Okay, now fourth question, with reference to the earth movement, consider the following statements. Earth's rotation on its axis from west to east causes seasons and year. Okay, so rotation does not cause seasons and year. Basically, it is revolution on a tilted axis. Okay, so or revolution basically that causes seasons. Okay, this first statement is wrong. Earth revolution around the sun causes day and night. No, it is rotation that causes day and night. So second statement is also wrong. So 1 and 2 are wrong. So you get D as the correct answer. That is neither 1, neither 2. Okay. Then look at the last question. With reference to the altitude of the midday sun, the sun is vertically overhead at the equator on 2 days each year, which is termed as summer solstice. Actually, when the sun is overhead the equator, it is called as equinox, but not summer solstice. So this first statement is wrong, because he is saying that it is summer solstice. Then look at the second statement. When southern hemisphere will have longest day and shortest night, it is termed as winter solstice. So in winter solstice, you basically have the shortest days and longest night in the northern hemisphere. Okay. Now this condition is reversed in the southern hemisphere. So let us say in the southern hemisphere we have days longer than nights. But look at the option here. When southern hemisphere will have longest day and shortest night. So longest day and shortest night, it is called as winter solstice. Okay, so winter solstice, because we have this condition in the northern hemisphere. So second statement is correct. That is B is the correct option here. So such questions can be asked in the UPSC preliminary exam based on the insolation. So I hope you have understood the topic. So we will discuss the further topics of climatology in the coming session. And if there are any doubts, you can post in the comment section. We'll try to address it. Okay. So thank you so much for attending this session. Have a good day.